Hi everyone, this is Dr.Senthil, Associate Professor, Department of II SNS College of Technology, and these are my mentees. Belongs to second year Electrical Electronics Engineering, and the mentee is Mr. Vasan, Mr. Guru Prasad, Mr. Salman, and Mr. Basha. Now, these students are going to discuss about a DT-based study on design of elevator, which comes under unit number 3, design of counter circuits, right? Now, let me discuss this DT-based study and the students starts.
So, elevator system can be used in a design thinking process. So nowadays, elevator can be used in many market stories, but still have facing crowd, time facing, but and button selection. So the users need clear clarification and improvement and design innovation. So we are making a elevator and making using design thinking process. The design thinking have 5 stages: empathize, define, ideate, prototype, and test. So the empathize part will be taken by Guru Prasad.
So in empathize stage, we discuss with many people and different users. So many of the problem statements are from the elderly people and working professionals. So some of the common problem statements are long waiting time during professional hours and working hours, and confusion when the multiple elevators arrive, delay in floors. So we understood that our problem statement is clear. We need our elevator should be more user friendly and efficient. So the solution will be explained by mate Salman.
So after defining the problem statement, we came to the conclusion that our solution must be simple and also efficient. That is, it should count both upward and downward without confusing with other flows and without making the circuit complex. So our idea is to use T flip-flop to make a mod 7 counter.
Okay, and this T flip-flop comes under synchronous sequential circuit. Therefore, these students will design a synchronous sequential counter with mode 8. You mean ground plus 7 flows. Now, let me discuss that design. The explanation of state diagram is handled by Mr. Salman.
So before designing a circuit, we need to understand the logic behind the circuit. So for that, we assume there will be 8 flows, including the ground floor. Since a counter or flip-flop can handle one bit, that is 0 and 1, we took 3 flip-flop, so that there are 3
values,
3 bits. So our counter should count both upward and also downward. So the logic is we should have an increment, that is 0, 1, 2, 3, 4, 5, 6 and 7, and also decrement, that is 7, 6, 5, 4, 3, 2, 1 and 0. So this increment and decrement is carried out by another signal that we assign as y. When y is 1, it should give a decrement value, and y is equal to 0, it should give an increment value. So it is a logic behind the circuit, and we will go to the circuit diagram.
And this is the state table what Salman has explained. Now let me, after the state table, excitation table is there, and after that we can design a circuit. The circuit is explained by our student.
From the driven came up, we got this solution. So according to the state diagram, we have 3 flip-flops, T0, T1 and T2. So T1 is in one stage, T2 is in one state, T1 is in 10 states, and T0 is in 100 place. So according to this equation, we need 2 gates, AND gate and OR gate. The clockwise is connected parallel to the 3 flip-flops. So it is in parallel means the name is synchronous sequential circuits. So we need AND gate, OR gate. From each flip-flops, the AND gate is connected, and the AND gate is connected again to the OR gate. From the Q2, Q1 and Q0. So my friend will take you over the next solution.
So I might explain how the circuit works. Now I explain the logic behind the circuit. That is, we found from the K map that the Q0 must be connected to VCC, that is positive. So that is connected the positive here, and Q1 T flip-flop as the logic of Q0 dot up plus Q0 dash of up dash. That is
2 AND gates. Yeah.
So you mean
Here one AND gate comes into picture, another AND gates, and this product combination is added with the sum. Therefore, two AND gates and one OR gate comes into picture.
So same as to the Q3, that Q2. Here, four, four AND gates and one OR gate is used. So coming to the circuit, that is the up is the trigger pulse that we give. We give both upward and downward pulses. So now for Q1, we are going to see how the logic is implemented in the circuit. That is Q naught, not Q not up. The up pulse is connected with Q naught in an AND gate, and it is that is summed with another logic. There is Q not dash and up dash. For up dash, we use a NOT gate to provide a opposite signal, and it is combined with an AND gate with Q dash, and it is added or summed with NOT gate with OR gate or with. So Guru will explain the next equation.
So according to this equation, the inputs are taken from this AND gate. So the previous equation AND gate, Q naught and UP is taken from this AND gate, and Q1 is taken directly from this flip flop. And the next input is taken from an previous AND gate, Q1 and UP naught, and Q1 dash is taken directly. So these two inputs are connected to an OR gate, and so we get the output.
In conclusion, our DB-based case study on elevator shows how the up and down counter logic helps the movement of the elevator. By using logic and state diagram, we can track easily every flow step by step correctly. This simple digital logic shows makes the elevator smoother experience and faster. Thank you.
Therefore, this DT-based study is explained by these second year triple students, and they designed this counter with the help of a T flip flop.